Hello everyone, welcome to the BOOKphilic YouTube channel. In this video, we are going to understand the types of a parser. In our previous lecture, we have understood what is a parser, what is the function of a parser, how the parse tree can be generated by using a given string. Okay, now in this case, we are going to understand the types of a parser. So a parser can be of two types. First of all, top to down parser, and second of all, bottom up parser. Now you will be understanding what do you mean by top to down parser and bottom up parser. You might have seen a tree. So we will be getting these types by using a tree symbols, by using the example of a tree. So let us understand. So first of all, let me draw the tree so that you can understand very well. Okay. So first of all, let us draw a tree. So here it is a tree, and here it is the land in which it has grown. These are the roots, and this is the leaves and stems of the tree. So let us understand the parser needs to generate this tree, okay, in two ways, from top to bottom, from top to bottom, B for bottom, T for top, and top to bottom or bottom to top. So you have already seen that a tree can be generated from bottom to top, isn't it? But how can be top to bottom? So in this video, we are going to understand the top to bottom parse tree as well as bottom to up parse tree as well. So let us understand. Okay. So first of all, the parser can be derived into two different categories, that is TDP and BUP. TDP is nothing but top to down parser, and BUP is nothing but bottom up parser. Bottom up parser, and in the next phase we are going to derive this TDP with full backtracking, and in the next we are going to without backtracking. And now in this bottom up parser, we are deriving this bottom up parser in two different categories again. This is operator precedence parser, and this is LR parser. And this LR parser is again derived into LR, SLR, CLR, and LR parser. And this TDP without backtracking can be again further derived into recursive descent and non-recursive descent parser. So we are going to discuss all of these types of parser, that is top down parser with full backtracking, top down parser without full backtracking, and without full backtracking we are going to understand the recursive descent and non-recursive descent, that is also known as LL1 parser. In case of bottom up parser, we are going to understand operator precedence parser, LR parser. And in case of LR parser, we are going to understand LR, SLR, CLR, LLR. So be tuned with this series of the parser because we are going to understand the most important topics of the compiler design. If someone can understand this whole concept of a parser, that is the syntax analyzer of a parser, this phase of the compiler, then half of the compiler design will be finished by the same person way who has understood this parser. Okay, so let us move on to the points which we have just written over here, that only operator precedence parser works on ambiguous branch. So here it is the operator precedence parser which will only work on the ambiguous branch. Now ambiguous branch, we don't need to say that what do you mean by ambiguous branch, because we have already understood what do you mean by ambiguous grammar. So ambiguity of a grammar is nothing but the ambiguous branch of the parser. So the ambiguous branch of the parser, that is ambiguous grammar, will be settled, will be operated by using this operator precedence parser. Okay, this is the very important point of this whole video. Okay, now we are going to understand the next point, that is top down parser does not allow left recursive grammar and non-deterministic grammar. Now, what do you mean by left recursive grammar? What do you mean by non-deterministic grammar? You cannot understand in this video because this is the another concept of the parser. So you will have to understand it in our upcoming videos. For the time being now, you just note it down, and in our upcoming videos, I must say that this point, what does it mean to say? So let us move on to the next point, that is the bottom up parser allows left recursive grammar and and non-deterministic grammar. And fourth point is nothing but the no parser allows ambiguous grammar except for operator precedence parser. So the first point and the last point, the first point and the last point have the same meaning, and second point and the third point has the same meaning. So you will be understanding this after few videos. Till now you can note it down in your notes, and I must say that this is the shortest notes that a compiler design chapter can have. So you must have to write it down in your notes. You don't need to write it again and again. You can write it, okay, and then understand it. And in our upcoming videos we are going to understand the top down parser and bottom down parser. Okay, bottom down parser or bottom up parser, you can say that. Okay, so bottom now parser is a phase of a compiler which takes as an input with the help of a cfg. Cfg is nothing but the context free grammar. It converts it into corresponding tree. Parser is also known as syntax analyzer. In this we are going to understand this variety of grammars. Grammar can be either ambiguous, unambiguous, left recursive, right recursive, non-deterministic, and deterministic. And top-down parser will not allow the ambiguous. This is the symbol of X, means it will not allow the ambiguous, but top-down parser will allow the unambiguous grammar, and top-down parser will not allow the left recursive grammar, but allow the right recursive grammar. It will not allow the non-deterministic grammar, but allow the deterministic grammar. Bottom-up parser will not allow the ambiguous grammar, except this bottom-up parser will accept all of these unambiguous, left recursive, right recursive, non-deterministic, and deterministic grammar. So we will be understanding elaborately in different ways, in deep, in brief manner, what do you mean by TDP, what do you mean by BUP, and its different categories. So for the time being now, till then, keep learning, keep earning. Thank you very much.